Okay, hi everyone. We're just getting started with Wild Voices Online. We're going to give it a couple of minutes for everyone to join us and log in, so just hold tight. While you're waiting though, I'm going to start a poll question just for fun. See if you can decide the answer to this question while we wait. Okay, so while you're waiting, you can think about what of these two do you think uses more energy? A new fridge or a new smartphone? You can just check which one you think. All right, and for folks who are just starting to join us, we're just settling in to get started for Wild Voices Online. We'll give it a couple more minutes still, probably one more minute before we get started to let folks log in. And I just have a question up there for you to think about if you can guess the answer to that. What do you think uses more energy, a new fridge or a smartphone? Okay, I can see a few more people join us in the last moment, but I have a feeling that's our group, so I'll just say one more time, just while we're waiting for everyone to join us. The question up there is a poll for you to answer. Just a guess, what do you think uses more energy, a new fridge or a smartphone? I'll give it just a few more seconds and we'll get started for today. Okay, I'm thinking we probably have everyone here. So I'm going to stop the poll now, and then I'll let you know which one it is. Since you've all guessed, what do you think takes more energy? A new fridge, a new smartphone? Most folks think that a new fridge takes more energy than a new smartphone. And it can depend on the fridge or the smartphone, but actually often a new smartphone might take more energy than a new energy efficient fridge. Just a fun fact for today. Oh, and actually I forgot to share the results. There you go. So you can see most people voted for a new fridge, but actually it's kind of a trick question. It could be a new smartphone. Okay, so I'm just going to take that poll down and we'll get started since we are ready to go. Welcome to Wild Voices Online. This is our first session that we're doing. This is actually part of a series of sessions that we're going to be doing on Wednesdays and Thursdays in May and June. I'm Christine. I work for the Columbia Basin Environmental Education Network. Normally at this time of the year, we're sending folks from our team out to your classrooms to do environmental and outdoor education. But since we can't come to you in person this year, we're coming to you online. So feel free to check out the options for what we have coming up at cbeen.ca/wildvoicesonline, and feel free to register for something that interests you. So now, just as we're getting started with the presentation, a few things to let you know about how this presentation will work. You are muted. We can't see or hear you. If you need to ask us a question, if our presenter says something that you want to know more about, or you just have something to let us know, a tech question just to pass on to us, you can click the little speech bubble in your Zoom options that says chat, a little speech bubble that says chat. You can send us questions through that, and your questions can only be seen by myself and our presenter today. But keep in mind, there's a lot more of you than there is of us, so be patient with your questions. Just ask your question once. Just like in a classroom, I might not be able to answer all of your questions about interesting things you hear in the presentation. I might just have to select a few, because I'll be watching for your questions and I'll be writing them down, and then I'll ask them to our presenter at a good break point to ask those questions. And of course, if you're using the chat to ask a question, just be respectful of myself and the presenter. And we, I think, are just about ready to get started. Before we do, I just want to ask a quick question of what grade you're all in, the folks who are joining us. So I'm just going to launch another poll here. If you can let me know what grade you're in. And there's a question there for if you're a teacher as well, you can select teacher. Okay, I see folks are answering, thank you. I'll give it about 10 more seconds. If you could just answer what grade you're in, 8, 9, 10, 11, 12, or if you're a teacher. Okay, I see a few more people are answering us. I'll give it like 5 more seconds. 5, 4, 3, 2, 1. Okay, thank you. I'll just quickly share. Most of the students joining us today were in grade 8 and 9. We have a few in grade 11, and we have a couple teachers joining us. So thanks so much. We will get started. So today our presenter is Ingrid Liepa. She's going to be presenting a presentation called Climate Action, Cool Solutions. And I'm actually just going to pass it right over to her to get started and introduce herself.
All right, thank you, Christine. I'm going to share my screen and we're gonna get going here. Oops, and we're gonna get rid of that. Oh, go away. Oh, here we go. Don't save. That can go away. Um, all right, and we'll get the slideshow set up. And here we are. All right. It's always fun doing things on Zoom online because you sometimes get some technical things happening that are deeply unexpected. And let's go then. All right, so my name's Ingrid Liepa. I'm proud to call Kimberley my home for the last 15 years. I've been doing climate change related work since about the 1990s, and my passion is around communicating and educating on climate change in a way that's engaging, it's thoughtful, and really, hopefully, inspiring. And so even though climate change can be a heavy subject, one of my biggest takeaways over all these years is that climate change can be some of the most rewarding work you could ever hope to do. It's definitely not for sissies, and yeah, it's yeah, you have to sort of be willing to dig in with tough questions and look at your own values and choices along the way. But like I say, it is deeply rewarding. And I'm just realizing I'm having a little technical hiccup here, Christine. So I'm going to exit out of the show for a moment. And I'm not sure why it's happening. Sorry, folks. I apologize. We did actually test this right before we started, and for some reason, it's not working right now.
On my end, Ingrid, I can see your first slide with your introduction and the image of you.
Yeah, so what's happening is I'm actually not able to get my mouse where it needs to be, which is very odd. Hmm. Oh, hang on. Oh, there we go. Okay, mouse is found. we can keep going. Sorry about that, folks. All right, so let's just start off with the fact that we live on an amazing planet. And as an overall umbrella for this presentation, these 4 words pretty much sum up what I've learned in the past 30 years. So it seems pretty obvious, think global, act local, but wicked problems like climate change really do have to be solved at all scales, all at the same time. So that really means that your actions at the micro local scale, like walking to school, are just as important as things like community gardens or solar farms or zero waste factories and global financial policies like carbon taxes. And so we can't really wait for one to come before the other. We need to act quickly, we need to act together, and we need to act now. So what are we going to do today? So in terms of a little overview, this is going to be a bit of an eclectic ramble through, we're going to touch on some climate science, some social science, some psychology, some history, some ecology, and perhaps most importantly, action. And all I can say right now is fasten your seatbelts because we're going to cover a lot of content in this next hour, but hopefully in a way that you find interesting and engaging. So I'm going to start off. Oh, look at that. Look at that spin. Okay. I'm going to start off with some things I learned back in my first year university when I showed up for my first class, and the professor said something very intriguing. He said, everything is connected to everything else, and there's no such thing as a free lunch. And I realized that what he was really talking about was the four laws of ecology. And these are 4 basic and inescapable laws that are operating in our world. And so, like I say, the first thing is that everything is connected to everything else. So ecosystems, of which we humans are a part, are completely interconnected. They have feedback loops. And so if one thing changes, it will be felt by everything else, even though we might not see a visible change. The second law of ecology is that everything must go somewhere. And so this is really a basic kind of restatement of the law of physics, that matter is indestructible. And so, one of the reasons that we are where we are with our current climate crisis and environmental issues is that we've taken great amounts of material and extracted them from the earth, we've converted them into new forms and then put them back into the environment without really taking into account the fact that everything has to go somewhere. And so the result is, we accumulate harmful amounts of things like carbon dioxide, for example, in places where in nature they're actually they don't belong in the quantities that that we've created. So this next law is nature knows best, and it's interesting because we live in a society that has a lot of technology and science and innovation, and sometimes has this mindset that we can actually do better than nature. But I think we're learning with things like climate change that we might have actually deceived ourselves a little bit on that one, and that ultimately we need to be digging deeper into what it means to actually align with nature, because nature indeed does know best. And then lastly is there is no such thing as a free lunch. And so because the global ecosystem is completely interconnected, and nothing can be gained or lost, and we can't actually sort of improve on nature, anything extracted from the ecosystem by human effort must be replaced. And so this is like, this payment of this price is something we can't avoid. We can delay it, but I'd say, the environmental challenges, climate change is actually a kind of a warning that we've delayed, if you will, paying back the price, right? And so those 4 laws of ecology, if you take anything away from this presentation, super important for like how we look at the world. So I'm going to go back into history a little bit, and if you don't recognize this figure, this is a statue of Leonardo da Vinci. Hopefully you've heard of him. And I love the quote he has here for us: "Study the art of science, develop your senses, especially learn how to see." And Da Vinci is a pretty amazing character. He lived in the 1400s and the early 1500s. He was an artist, an engineer, a thinker, an inventor. He was also a vegetarian, he was gay, he was illegitimate, he was left-handed, he was really popular, and he was a bit of a heretic. Like he challenged the way people thought. And he also didn't have any formal academic training. And so, but what he did have was unquenchable curiosity and what's been described as a feverishly inventive imagination. And he's widely considered to have been one of the most diversely talented individuals ever to have lived. And I think he tells us something really important about really being curious about our world, and really seeing the interconnections between the everything, and studying the art of science. So this takes us on to a race we must win. So this is, you're probably wondering, okay, why am I seeing a sailboat right now? Well, this yacht, it's a world-class racing yacht, and it was actually the yacht that Greta Thunberg sailed across the Atlantic on last year. And so it's a zero emissions boat, and the team that owns the Malizia, they're completely dedicated to 3 things: research, environmental protection, and youth work. And you can see on the sail there, the slogan is "United Behind the Science." And so that's been a really big message that Greta Thunberg has really brought back to the world, if you will, and as a young person, about emphasizing the importance of looking at science and climate change. All right, so hashtag science matters. So the first thing to know about climate change, that it is not a matter of opinion or politics. Like our cartoon guy here, often people have an opinion about climate change based on what they see out the window in a season or maybe on the daily news. But I'm here to say that the science really matters. It's the only way to know how much and how fast our planet's climate is changing and how effective our actions really are. So this is a new little click there. So one of your top things to know is that when we think about and talk about this topic, we need to stay rooted in the science of the Earth's carbon cycle, the measured sources of carbon, and how that carbon affects the Earth's temperature. All right, so stepping back into time, I'm just going to grab, can I grab the annotate here? Okay, hopefully you can see my mouse. And so this is a chart that goes back 800,000 years, and it shows us. So it's showing the amount of carbon dioxide that was in the atmosphere up to 800,000 years ago, as well as the temperature. And so we now know that the amount of carbon dioxide that was in the atmosphere and the temperature actually sort of cycled together over these last 800,000 years. And so these cold dips, when there's less carbon dioxide, that's when the Earth was covered in massive sheets of ice, the ice ages. And the peaks here, where there was a bit more carbon dioxide in the atmosphere, these were warm times, basically how it is now, kind of perfect for humans. And the takeaway here is that the difference between massive ice sheets and temperatures that we really like is only about 4 to 5 degrees on a global level. So yeah, and so if we look at where we are today, this is how much carbon dioxide there is in the atmosphere, and that represents about another 4 degrees of warming potential. So these are, these are important things to keep in mind, like just understanding the background of what's happening. And so this is just a quick snapshot of what the Earth looked like at the peak of the last ice age. You can see basically most of the northern hemisphere was covered in great big ice sheets, and on the right side is where it is now. And the difference is about 4 degrees between these two periods of time. So let's look a little bit more at what I call the circumstances affecting the heat of the sun's rays. So our modern day understanding of climate change began in the 1800s. So this is just a little history piece. So there was a French mathematician and physicist who in the early 1800s figured out that he did these mathematical calculations, and he realized that, wait a second, if the sun's radiation is not enough to heat, to create the temperatures that we have here. So he figured that the atmosphere must be having a role somehow in making it warmer. And then there was Eunice Foote. She was an American scientist and inventor in the 1850s who did some simple experiments by putting different gases in jars and putting them out in the sun and seeing like which ones warmed more than others. So she really is the one who discovered that carbon dioxide traps heat much more than other gases. And then in the late 1890s, there was a Swedish physicist and chemist. His name was Svante Arrhenius. And Arrhenius was really the guy who put it all together and realized that kind of that direct relationship between carbon dioxide and increasing the Earth's surface temperature. So he kind of created the foundation for our first climate models. So we've known about this for a long time. So the greenhouse effect, just really quickly, hopefully you've had this before, so hopefully this is review, but if not, we'll walk through this. So this is the Earth without the atmosphere, getting heat from the sun, and without, whoops, let's just go back there for a sec. Oops. All right. We're having, animation is having fun with me. Yeah, so the sun, the heat comes in, it gets beamed back out. And so the Earth would basically be an ice ball without an atmosphere. So here it is with an atmosphere, the sun's heat comes in, it gets reflected out, but some of it gets reflected back in, giving us about a 15-degree temperature. But with more carbon dioxide in the atmosphere, we get more heat reflected back in. And so that's like the real basics of the greenhouse effect. All right. Oh, and we are just going to move along here. Okay, so what that means is that carbon dioxide is actually acting like a control knob for the Earth's atmosphere. And so, yeah, I think at this point, you know, we can safely say the more that there's greenhouse gases, and there's more than carbon dioxide. There's methane, there's nitrous oxide, there's chlorofluorocarbons, which are actually refrigerants. Like yeah, they're all there. And when we look at the Earth's atmosphere, here's where it gets super interesting, because this little pie chart shows us the composition of the atmosphere. And when we look at carbon dioxide, which is this pink here in this like tiny sliver, it's 0.038% of our Earth's atmosphere. So, you know, just these, you know, it may not seem like a lot, but it has an incredible impact on this planet being livable. And then you can see like these minute traces. There's some other greenhouse gases in here. So we're talking about a tiny fraction of the atmosphere that really, really matters. All right, so here we are on Earth. So I'm going to talk a little bit about the carbon cycle. And so, I mean, carbon is a good thing. All life is made of carbon. And it's really the building block for all life on Earth. So we need it. And, you know, so the main message here is we've gotten out of balance with it. And, you know, since the beginning of the Earth, the carbon atoms have been, you know, relocating and recombining into different forms. And, you know, again, this has all been happening through nature. And we're just learning the hard way that we haven't actually improved upon nature's natural carbon cycle, and really that there's no such thing as a free lunch. So understanding this, you know, what's happening here with the carbon cycle is kind of critical to understanding what we need to do about climate change. So most of the Earth's carbon is stored in rocks. So that's all this stuff down here. 65.5 billion tons of carbon is stored in rocks. And the rest of it is up here in the atmosphere and the plants, soils, fossil fuels, and in each one of these are called a reservoir. And, you know, they're in the atmosphere, plants and soils, that's called a fast cycle reservoir, where carbon's actually moving quite freely. So when carbon goes up into the atmosphere, it might spend, like in the form of carbon dioxide, it might be up there for a number of decades. But if you think about the slow cycle of carbon, like once it gets embedded in rocks, it could sit there for like 100 or 200 million years. So yeah, it's super interesting. And we're going to go on to this little video that's going to put this in, it's kind of going to bring this all together, everything that I've been talking about. So we'll just sit back and enjoy. It comes from NASA.
That ours is a precious planet.
NASA has unique capabilities because we have the point of view from space. With NASA's carbon monitoring system, you can see the amount of CO2 in the atmosphere decreasing in the spring and the summer. Plants of the oceans and the land surface are greening up and pulling the carbon dioxide out of the atmosphere. And then in the fall and in the winter time, you'll see the CO2 in the atmosphere increasing because plants and animals are releasing the carbon dioxide that was captured during the growing season. There is a graph called the Keeling curve, where you can see the summer and winter cycle. The process is very natural. Contrast that with old slow carbon. So this is a chunk of coal. It was also made by plants. It also contains carbon dioxide that was in the atmosphere. But the carbon in this chunk of coal was taken out of the atmosphere 350 million years ago. And since the Industrial Revolution, we've been taking it out of the ground and using it for a fuel. The burning of fossil fuels, whether it's coal, oil, or natural gas, has released this very, very old carbon back into the atmosphere a lot faster than the oceans and the plants on the land can take it out of the atmosphere. It's bit by bit moving the Keeling curve up. (1989) was the last time we saw 350 parts per million. And it appears that 2016 will be the last time that CO2 has dipped below 400 parts per million. And what the heck is 400 parts per million? What does that even mean? Well, we know from the analysis of ice samples from Antarctica that before the Industrial Revolution, the amount of carbon dioxide in the atmosphere was about 275 parts per million. It had been this way for thousands of years. Something has increased the number from 275 to 400. We're quite certain that that is due to the human activity of burning fossil fuels.
I take these satellite measurements and the variation over time of how the world is changing as facts. We've seen this warming over the last century and a half, very, very meticulous measurements, and it shows a really sharp acceleration in the warming over the last 4 decades.
People have a hard time understanding what's a big deal for a planet that is warmer by a degree or warmer by 2 degrees Celsius. But the impacts that we're worried about are being triggered not at a 20-degree warmer world, but they're being triggered at a 1-degree warmer world.
Over the last decades, we've seen the ice melting. We've seen the ice melting at the North Pole. We've seen the ice melting really fast on Greenland, where it's falling off Greenland into the ocean.
We've had Pacific Islands that have already had to be abandoned because of sea level rise. We can combine our data with global climate models and say, how is sea level going to change over the next 5, 10, 15 years? Because if we continue on the path we're doing, there's going to be a lot of coastal communities all around the world that are going to be flooded.
As scientists, we're just taking the most precise data that we can. It's open data, it's factual. For instance, the enormous droughts and fires that we have around the world are directly related to a warmer planet. That has a huge impact on people. It's unprecedented.
If you have a warmer atmosphere that can hold more moisture, because that's what warmer atmospheres do, they can suck up more moisture, that means more convection, more big thunderstorms, more hurricanes, more extreme weather. That's one of the likely outcomes of a warming world. We've built our civilization around the current climate, our coastal cities, our food resources, our water resources. They're all pegged to the current climate, and there's not much slack in the system.
We're already seeing impacts, and impacts are going to increase. In a 2-degree warmer world, there'll be more. And in a 3-degree warmer world, there'll be even more. And when you're looking at those kind of scenarios, 3, 4, 5 degrees warmer, which are totally plausible, If we go down that path, we will be looking at a different planet.
Okay, so Christine, I'm just going to check in if there's any questions.
I do have a question. How did you get interested in climate change and global warming?
Ah, well, wow, I have to really kind of go back. Okay, so it's in the 90s, and that's when really people started to, it started to hit the news that there might be something going on with climate change, with the atmosphere. And uh, in some ways you could say I just stumbled into it in that I was working for a company that was associated with, well, being part of the problem. They were a power generator, and so I was asked to do some early research and pull together information about it. And so that was really how I stumbled into it. And then when I realized that climate change was actually giving us an opportunity to sort of rethink and relook at how we do things in the world. So remember, when we go back to the first basic laws of ecology, about everything being interconnected, that everything has to go somewhere, there's no such thing as a free lunch, that climate change would actually potentially be a way for us to get back on track, and to live in a more environmentally sustainable way on the planet. So that's how it all started.
All right, thank you, Ingrid.
Yeah.
That was the one question I've gotten so far. So students watching the presentation, if you have a question during the presentation, feel free to ask it in the chat. You can ask it at any time because I'm writing them down here for you to ask when Ingrid's ready. So go ahead. If you have any questions on your mind, feel free to type them to me and I'll ask them for you when we're at a good pause point.
Okay.
Back to you, Ingrid.
Okay, we're going to steam ahead here. So, here we go. All right, so this is basically how humans have been putting carbon dioxide into the atmosphere since the 1850s. So we're, somewhere around 2 million tons as of when this chart was done. And if you're interested to see where, kind of where it's coming from in terms of different countries or parts of the world, this shows us. I know the print is really small, but not surprisingly, Europe, United States, Americas, and China are the largest sources of carbon dioxide emissions. So where is it all going? Well, the oceans have actually played a pretty key role. So 30% of the carbon dioxide has been absorbed there. And it's actually resulting in a slight acidification of the ocean as the carbon dioxide combines with other things in the ocean's chemistry, creates carbonic acid. So 25% has been taken up by plants and vegetation. So you'll often hear that, trees really like more carbon dioxide. They grow, it's like fertilizer in the air, if you will. And then, the other 40% has stayed in the atmosphere. So this is kind of the, that second law, everything has to go somewhere. So this is showing you where it's going. All right, and now let's look at the major global sources. So globally, electricity from and heat from burning fossil fuels is the #1 source of greenhouse gas or carbon emissions. #2 is industrial production, things like mining and forestry, and then making stuff from all those natural resources. And then #3 is transportation, basically moving all that stuff and people around in planes, trains, ships, and automobiles. So stepping back, obviously, keeping the lights on, keeping warm or cool, and making stuff and moving around are all things we want to be able to do in the future. So we'll be getting shortly to some thoughts about what that could look like. But first, we're going to do a quick visit on the Columbia Basin. And this is what greenhouse gas emissions look like in the Columbia Basin. So it's a bit different than the global view. So here, industry is our top emitter. Transportation is #2. And heating and cooling our homes here in the red part is #3. And emissions from rotting food waste at the dump is 4th. So again, surely we plan to keep making things, moving them around, keeping warm at home, and wasting lots of food. Oh, wait, actually, maybe we could stop wasting food today. This is an example of a simple but important climate leadership action that reduces powerful methane gas coming from landfills. So what has all this meant for the climate in the Columbia Basin? Well, this chart is a chart of actual temperature data that's been collected for over 100 years from climate stations in the Columbia Basin. And it tells us that the temperature has actually gone up by about 1.7 degrees. That's the average annual temperature since 1915. And so you can see this graph is really spiky. And so we know that we have cold years followed by warmer years and then vice versa. And this variability from year to year can be a bit deceptive. We can actually fool ourselves that things aren't changing. So here's again, why science matters and unite behind the science. The actual historical temperature data that has been carefully collected for such a long time is actually, telling us what is going on. All right, so what does this all mean for us in the basin? A changing climate means changing impacts. And I've hosted probably over 70 climate change meetings in the basin over the years. And we always ask people what they're noticing that's different, different than 10 years ago or 20 years ago. And we really hear some most amazing things. And we see how basin residents are really paying attention to their environment, the landscape and the living things around them, and that's a great thing. But in short, what we're looking at is hotter, drier summers, warmer, wetter winters, more extreme rain events and snow events, and more extreme weather. And that means more wildfire, flooding, and drought risk. And it's something that will impact really our lives in subtle ways, and indirect ways, and in direct ways. So I'm not going to spend a whole lot more time on that, but next I'm going to show you an amazing climate resource that was created by the Columbia Basin Trust and Selkirk College. And this is like your go-to source for information about climate change in the basin. And we're just going to click out here. And if you go to the website, this is what it looks like. And let's see if I can get my mouse there. Great. And you can see here that there's information about communities. So every community in the basin, you can download like a 2-page climate profile. And you just do that by clicking on there. And if I click on that, that'll bring up a profile. I'm not going to do that right now. And Christine's going to put the web link in the chat box so that you can pick it up. If you want to learn about impacts in the basin, like if you want to learn about impacts on nature, you can scroll down through here and you'll see that the map might actually change. And so it'll automatically light up with different other map layers. This is biogeoclimatic zones that basically tell us like what kind of ecosystems are where. And let's see, these are glaciers that have just popped up. So there's a lot of stuff in here that you can browse through, and you can click on any of these Learn More tabs and they'll take you to other links. There's a directory of actions that are happening in the Columbia Basin. Let's get rid of the species at risk. And so you can click on any one of these. You can search by location, and yeah, you can search in different ways. And so learn about some of the climate actions happening. If you're interested to learn about climate science, there's a whole series of 2 to 3 minute videos that talk about different aspects of climate science, and that's all summarized in the sidebar here too, if you prefer to read. And then lastly, you can go out to the climate map and you can look for specific climate information for your community. So I live in Kimberley, and if I'm interested in the average temperature here in Kimberley in the 1960s, because it's always good to look at the past, and I'm gonna go click here and I see, okay, it's 5.28 degrees. Great, well, what's that gonna look like in the 2070s? And if this is gonna upload for me, There we go, and mean annual temperature in the 2070s. Sometimes it takes a moment, and I see, oh, okay, it's like when we look out to the future in a high emission scenario, it could be a lot warmer here. So there's lots to see here, and I encourage you to take a look, whether you're teacher or student, to see what's here. So we'll go back into the presentation. And Christine, oh, I'm going to show you one more resource I think that would be of interest. And this is about calculating your ecological footprint. So between the basin climate source and the ecological footprint, these are two things that you can do to learn more about climate change, your own footprint. So if I go to this website, I can actually calculate my carbon footprint. I'm not going to do this right now, but I'm just going to show you what the first page looks like. So it asks you questions like, how often do you eat animal-based products? Because we know that everything that we eat has a carbon footprint associated with it, and it gives you choices of never through to very often. And if you want to get more accurate, it'll ask you different kinds of meat, or even eggs, cheese, and dairy. And so each one of these things has a different footprint. So it's pretty cool. It's easy to do. It's interesting. Encourage you to take a look at that. All right. I'm not going to summarize because I see that we've got still a bunch of stuff to go through. Really want to go through solutions. Christine, is there anything really key in terms of questions?
All right, I did have a few questions come through while you were presenting, so I'll ask a couple right now. I did get all your questions, but I'm just going to focus on a couple just to be aware of the time we have available. I was wondering, I had a question that was, what do you mean by no free lunch?
Well, it just means, yeah, so what it means is that, when everything is going to have impact, even if we can't see it at the time. And so in terms of, sort of resource extraction, it goes back to the basic principle of sustainability. And if we don't pay attention to sustainability of our natural systems, like in the balance of those natural systems, then, like I say, for a time, it may seem like they're very abundant and we can just keep taking, but if we're not given, and that's the free lunch, I'm going to say the illusion of the free lunch. But once systems are stressed to a certain point or taken out of balance, then they shift, and so we no longer have a free lunch. Hopefully that.
I think I understand what you're saying, Ingrid. It's that there's all these resources out there and they look like they're free because we keep taking them, but there's actually a cost that we can't see right away.
Yeah, correct. And in our economic system, we've not really put a value on them. We've not really put a value on clean air. We've not put a value on clean water, in a way that helps us really embody that in our decision making.
Great, thanks. And I have another question. If someone's just wondering what you mean by a footprint.
Yeah, so the footprint is, if you think about it in terms of all the resources that are needed for you to live the lifestyle that you're living. And so you have your actual footprint, right? But then if you sort of extrapolate out and think about, where all your food comes from and where all your, like all the things that are involved with making the computer or the device that you're watching this webinar on right now, like that's an enormous footprint that goes well beyond your 2 feet. And so each one of those activities that help produce those things and bring them into your house and into your world have impact. And that's what we're measuring with the footprint.
Great. Thanks, Ingrid. I think I'll leave it for those 2 questions for now. I have some more that I'll save for another question period.
Okay. And
thanks everyone for sending so many great questions. You can keep it coming.
Yeah. All right. So we've got a choice point. And this particular chart kind of shows us our choice point. We are here in 2020 And these are different pathways of emissions, greenhouse gas emissions globally. So this line here is like kind of the historic, and you can see if we just keep on doing what we've been doing for, for the last 150 years, we're just going to get more and more greenhouse gas emissions in the atmosphere, and it's going to get really hot, basically. And what we want to do is we want to bend this curve. We want to be down here with the red and blue curves, because this is what's going to keep our planet down at a temperature that is livable. There will still be some change, but it will be, what the scientists are telling us is it will still be sort of within the realm of livable, manageable for most humans. There may be areas where it gets too hot to really be inhabitable anymore, but on balance, we still are living in a livable planet. So this is where we need to go, and so that's these are pretty major reductions that are ahead of us. But here's the neat thing. We have this pandemic, and there's nothing neat about a pandemic, so I just want to be really clear about it. But it's showing us something really, really important. And so some of you may have seen these curves before, or you've heard about, with the COVID-19, we need to flatten the curve. And so we're doing that by some pretty simple measures, really. We're staying at home, we're washing our hands, we're keeping our distance from each other. And so, here's, science has identified, this globally disastrous problem of COVID, and the actions that we're taking are pretty simple in terms of like keeping that pandemic at bay and bending the curve. Now, there's a lot of other things going on that I say in terms of jobs, of industry, and so on, that are having serious impact, and we will get through this. But there's also some very important learnings here in terms of climate change. So this is kind of, if we look at that same curve in terms of climate change, like here in BC, we're doing a great job of bending the curve. And, so if we do nothing, similar to COVID, big problems. But if we can agree to act together all at once, like we have more or less been doing with COVID, we get a more manageable rate of change and much less harm. And like the interesting thing to me is that both COVID and greenhouse gases are invisible. COVID is a virus, it causes a fever for humans, and greenhouse gases, well, if there's too much of those in the atmosphere, they cause a fever for the planet. So some interesting metaphors. So here's some neat things that are happening. So cities around the world that have been polluted are seeing blue sky for the first time in terms of, like I say, air pollution. And and people are sort of realizing like just how precious clean air is, and they're starting to question, do we really want to go back to where we were before? So this is really giving hope that as we emerge from this pandemic, from this COVID crisis, that there's going to be more interest, more support of the value of having like a more green and clean economic recovery. And the other thing is that carbon dioxide emissions could fall by 8% this year, which would be the first time in 150 years or so that we're actually starting to flatten and bend the curve. So there's some silver lining in terms of this very challenging situation that can really help us through on climate change. So I'm going to go to solutions now, because this is the part I think that's super fun. And not sure why, there we go. So let's talk about food and shelter. I'm going to start with the burger. Everybody loves a burger. This burger is a very special burger because it's actually a carbon negative burger. The burger chain Burgerville worked with some ranchers in Oregon and Washington, And the way these ranchers are ranching their cattle, it's actually pulling carbon into the soil. So it's a form of, regenerative agriculture and ranching that means that this burger, yeah, there's actually more carbon being sequestered, taken out of the atmosphere per kilogram of beef than, yeah, it's amazing. And so, starting to rethink our food systems so that they can, not be so extractive, right? So that we're putting back into the soil. This is that whole piece about everything's got to go somewhere. There's no such thing as a free lunch. When it comes to soil, if we start putting back, we can start taking carbon out of the air. This house is actually in the Kootenays, up in the upper right, and it's a house that is basically a zero emissions house, and you could heat it with a hairdryer. So very little energy footprint there. And then this is an actual community that's being developed in Holland. It's completely, they say, self-sufficient in terms of growing its own food and vertical gardens. It's a net zero, like no carbon community, no cars or anything like that. It is, yeah, it's pretty neat, and I wish I could spend more time talking about it, but we got to move on. So transportation, lots of neat things happening right here in the Kootenays in terms of Accelerate Kootenays. First rural region in Canada to have a regional electric vehicle charging network. So you should find those charging stations in your communities. If you haven't seen them already, we have car shares. We have car shares with electric cars. There's electric bikes. In Sweden, they're actually looking at electric highways. So these are all ways that we can look at transportation differently in order to, reduce our carbon footprint. And just walking, biking, or not taking trips at all, that's huge. Do we really need to make that trip? All right, these are more big ideas. So there's a lot of, so one of the big solutions is reforestation. And so this engineer that worked for NASA, he was actually, his job was to look at how to terraform Mars. And he said, wait a second, we need this here on Earth. And so he invented a drone that can actually plant, like I say, 300 seed pods in 18 minutes. And I know, like, Canada's actually made commitments like to plant 2 billion trees over the next 10 years, I believe. So technology that's going to help us do things like that. And that's something that can happen all over the world. More big ideas, the circular economy. So this addresses those 4 ecological laws. Instead of like extracting stuff, manufacturing it, using it, and throwing it away, the circular economy is asking us to like think completely differently about how we use stuff, design stuff, so that we completely minimize waste. And so if we actually are able to take that circular economy to heart, that could be like half of our carbon dioxide reductions by 2030. And so this is, I can't say enough about learning about the circular economy, because it's a very powerful way to now be looking at how we do everything in our world. This is a company in Squamish, BC, that's invented a way to suck carbon out of the atmosphere. And so they've demonstrated this technology, and this is like a big scale version of it that you're seeing on the slide here. And so that CO2 that gets captured either would be stored in the ground, but it could also be made into ultra clean synthetic transportation fuel. And so that would be an example where you just suck carbon out, make it into fuel, burn it, but it's ultra clean. And so you just keep that cycle going. You're not adding to the overall carbon load in the atmosphere. Let's see. India has decided to, it's made a huge commitment to go solar and to be a leading solar nation. And in Alberta, like they're now yeah, the oil industry is having its challenges in terms of drilling. And so the drillers are actually now, instead of drilling for oil, are looking at drilling for geothermal energy, which is like basically extracting heat from the earth and using that instead. And so it's a clean form of energy. And so this is just a schematic of a new form of geothermal that, you know, is super clean. Yeah, so many things that are going on, and this is like circular economy. A library is circular economy. A thrift store is circular economy. This fridge that recovers, this is Healthy Kimberly, and I know this is happening in other places where they take food from restaurants and grocery stores that still edible, but they say the grocers and the restaurants don't want to sell it. They collect it and they distribute it out in the community. They take it out of the waste stream. So, you know, reducing our food waste is just like, if there's a mission there, that is a great one, because that's something that is really in our control. So Canada is looking to be net zero emissions by 2050. BC similarly looking to reduce its emissions by 80% by 2050. There's a movement here in the Kootenays to be 100% renewable by the 2050s. So lots of policies and targets out there. We have international frameworks that are amazing, like the Sustainable Development Goals. These are ambitious and beautiful goals to, you know, really build a better world by 2030. If we pay attention to these, we really will build a better world. So teachers on here, I encourage you, if you're not looking at these, bring them into the classroom. If the Sustainable Development Goals are the what, the Earth Charter gives us the how. You know, it's about respect and care for the community of life, social and economic justice, ecological integrity, and democracy, nonviolence, and peace. So these are great reference points as we think about our world going forward. So our thoughts create our realities. And so this is, you know, staying in that place of curiosity, of imagination, and looking at the stories we tell, because that's what's going to create our future. You know, we have everything we need to actually go solve this climate crisis. We just need to get into motion. And this great quote, "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has." And so, you know, we are the ones we've been waiting for, and it doesn't matter what age you are, we're all in a place where we can make a difference on this. And again, Greta's story started when she was 15 and she didn't know what to do. So she sat on the steps of the Swedish Parliament, and you know, last year she was Times Person of the Year. So age is not a barrier. Lots of ways it's something, like I say, bring an imagination and a creativity that is really important right now. And just a shout out to Greta. These are, I looked on the Fridays for the Future website, and this is a world map, and it shows all the locations where there's going to be a Fridays for the Future gathering this Friday. So even though the world is in pandemic, they're finding safe ways to gather and to continue the support for climate action. So this is 2,267 gatherings scheduled for Friday. If we look at who's needed, well, I can link climate change and climate action to just about any job that you can think of. This is just a little snapshot, like whether you're interested in arts and storytelling, whether you're more of a scientist, whether you think you're going to be a teacher, educator, or you're drawn to government, or you just don't know. You know, there's places in business and industry. If we're really thinking about, hey, how can we do this differently? We can do climate action just about everywhere. So I'm just going to wrap up here in my last minute. What could you do this spring? Well, there's lots of possibilities. I mean, this is just a general list of the types of climate action projects you could do, like in terms of doing education or informing. get your hands dirty. You could look at ways to reduce waste. You could make different choices when you buy things that maybe buy nothing because you actually don't need it. You could decide to do your transportation differently. So lots of possibilities here. I'm going to give you 3 concrete projects, and I'm going to wrap up. So number 1, you could choose any one of these or all 3. Find 10 examples of climate action in your community, and go and actually talk to somebody who's doing one of those projects and learn more about what inspired them. Number 2, design a food garden for your home. Have a look at, what you could do in your front yard, your backyard, your balcony. What could you do to grow more food at home? And then the last is, actually look at how the COVID pandemic travel restrictions have changed your family's greenhouse gas emissions. So how has your carbon footprint changed? So those are 3 really concrete things you could do to take your curiosity and take your learning the next step. So with that, I am done. And wow.
All right. Thank you so much, Ingrid. I learned so much today. Thank you for presenting all of that. I think I'll just ask 2 questions to wrap it up. First one's just a quick question. If you could just say the name again of that community with the self-sufficiency zero emission plan.
Right. It is, let me just find it here. I have it. It's a suburb outside of Amsterdam, and it's by a company. It's designed by a company called Regen. And as I go back and look for it, here we go. It's called Almere.
Almere. Okay, perfect.
Yeah.
And then one last question to end on. I think it's a great question to end on. Why do you teach students and people about climate change?
Because I'm 2 reasons. I mean, number 1, I think it's so valuable to be curious and learn about the world around us, and to understand all the different ways that we're connected with each other, with all life forms, with sort of all the different forms of human enterprise. And I do it because I'm hoping you'll get as excited as I am about what we can do in terms of building a better, healthier, more resilient world.
All right, thank you so much, Ingrid. I think that's our time for today. So we'll be signing off now. Thank you everyone for joining us. We hope you have a great rest of your day, and feel free to join us for a future Wild Voices online session as well. All right, bye everyone.
Bye.